In this lesson, we will be using the ideal gas law, PV equals nRT, to solve for the density and molar mass of a gas. So let's start with the molar mass. So first, let's pretend we have 12 grams of carbon. How many moles do you have? To do that, you have to drop the undesired unit, which is grams, carbon, and 1 mole. The molar mass of carbon is 12.01 grams. So you have about 24 divided by 12, you have about 2 moles. Okay, so the symbols for these are as follows. The symbol for mole is lowercase n. The symbol for grams is lowercase m. The symbol for molar mass is uppercase M. Okay, so to get 2, we had to take 24 divided by 12.01, right? Is equal to 2. This formula says that you take 24, which is the mass, divided by the molar mass, which is 12, is equal to n. Okay, so this is very important. Pause the video if you did not understand on how this was derived. Okay, so to get the molar mass of a gas, all we have to do is take this m over m and plug it into PV equals nRT in there. Okay, let's do that. So first we go PV is equal to nRT, where you have the n right here. You're going to plug in little m over big M. So PV is equal to little m over big M RT. Okay, next, what we're going to do to solve for molar mass, the symbol for molar mass again is big M. So all we have to do now is do whatever we can to get m on one side and we can get the formula. Okay, so then we're going to a different color here. To get m on one side, what I'm going to do is multiply both sides by m. So I get m in the numerator. So I'm going to get MPV is equal to MRT. Then I'm going to divide by PV. So the molar mass is the mass times R times T over PV. So this is the formula for molar mass that you have to derive every time from PV equals nRT. I am not going to give you this formula and you are not going to memorize it either. You must start with PV equals nRT, substitute this for n, and then solve for big M. To use that, we have to do an experiment called the Dumas method. Okay, so this is how it works. First, you take a flask. This is a flask. And you take a volatile liquid. That means the liquid will turn into gas below 100 degrees Celsius, which is the boiling point of water. Okay, this is water. So this gas must boil below 100 degrees Celsius. So you heat up the water, which heats up the gas, and the gas turns into gas. You heat up the liquid, and the liquid turns into gas. And this is open to the atmosphere, so the gas comes out this way. Okay. Once all the liquid turns into a gas, you check the temperature. Okay. Then you seal it, and you weigh the flask. Remember, there's no more liquid. It's all gas in there and the flask. So the flask with the gas only, with no liquid, weighs this much. And so make sure that you also weigh the flask before the experiment when it was empty, which would weigh this much. So how would you know how much the gas weighed? Well, just subtract these two and you'll know how much the gas weighed. Okay, so to get the molar mass of a gas, you need the following. from the derivation right here, I'm going to use nRT over PV. Okay, so to get the mass of the gas, you have to subtract these two numbers. So 78.416 minus 77.834 is equal to 0.582 grams. That's the mass of the gas. 0.582 grams. Okay. R is 0.0821 liter ATM Kelvin mole. Okay. Temperature is given here. So the temperature is 100 degrees Celsius. Actually, this should be, your water should be boiling already because the liquid has to be all in gas. So your temperature of boiling water is 100 degrees Celsius. And you have to convert that to Kelvin. So 273.15 is equal to 373.2 because your thermometer only has one decimal place. Again, the reason I'm using the temperature to be 100 degrees Celsius is because your water is boiling, which means that all the liquid has turned into gas. Okay? So the temperature is 373.2 Kelvin. The pressure. So because before you sealed it, the gas was able to come out, right? So the pressure inside is the same as the pressure outside because it was open to the environment. Okay, so that means the pressure outside is 1 atm, about 1 atm. Okay, but it's a little bit lower, so you have to convert this to atm. Okay, so you divide it by 760 torr. 1 atm is equal to 0.992 atm. And you plug that where pressure is. 0.992 atm. Okay. Now the volume of the flask, what you have to do is then figure out how much volume this flask has. You can do that a few ways. You can fill it up with water, of course after the experiment. You fill it up with water to the top and then you use a graduated cylinder to measure how much water it took all the way to the top. And they got the volume to be 213 milliliters, so you have to convert that to liters, divided by 1,000. 1,000 milliliters is 1 liter. So 0.213 liters. Okay. So when you plug that in the calculator, you type in 0.582 times 0.0821 times 373.2 divided by 0.992 divided by 0.213. And the answer should be 84.4. Okay. So then you have to cancel the units. So the liters cancel here and here. The Kelvin will cancel here. The ATM cancel. The mole does not cancel and the gram does not cancel. So you have to write those. So it'll be grams per mole, which is the unit for molar mass. So what you've done is you've gotten, using PV equals nRT, okay, you substituted N to be M over M here. You got the formula for molar mass. You plugged in your numbers using the Dumas method, and what you did was you took a liquid, you put it in boiling water, the liquid turns into a gas. The boiling point of your liquid must be below 100 degrees. So it's all gas in there. And you got the temperature of the boiling water, which is 100, the volume of the flask, which is this. The pressure inside is the same as the outside, so 754, change that to atm. The mass of the gas inside, and you subtracted the mass of the gas in the flask minus when it was empty, 0.582, and you just got the molar mass. By obtaining the molar mass of a gas, you can get the identity of the gas. So that's why it's very useful to get the molar mass of a gas.